Good afternoon, everybody. My name was pronounced almost perfectly, but it's Michele, not Michelle. It's an Italian pronunciation. Otherwise, my family name was pronounced perfectly. Thank you very much. So once more, hi, everybody. Today, in these few minutes, I will briefly touch the topic of unlocking the power of people counting data from lift sensor, already available lift sensors. So I'll never talk about new additional sensors that you will have to install on an elevator, but actually extracting those kind of data from existing sensors. But let's start one second beyond that and start talking about, in general, smart buildings. Smart buildings, behind the smart building, the digital transformation is the driving force that pushes smart building. And behind any digital transformation, there is data. So the real golden in any digital transformation is data. And here, that's what's all about. It's about capturing this data. Yes, smart buildings become, thanks to that, more efficient, sustainable, and user-friendly. Vertical transportation, it's an important part of this smart ecosystem. Of course, vertical transportation are transportation means, but they are now becoming more than that. Lift become people counting sensors themselves. So I really see the lifts as sensor in the elevator. And that's what I will try to articulate here in my few slides about it. So let's start maybe with the simple scenario, and my apology, I start with the code and standard from North America, but because this is the easiest scenario. In North America, the new standards for safety requires detecting person or object between the door, as anywhere, but also approaching the lift, so in front of the door, the area of that. And that's a new standard in the North America, released in the 2019. And there are products already, of course, available in the market for that. And a solution to comply to that is to combine, I would say, a conventional light curtain with a time of flight 3D camera observing the area in front of the door. Okay, so fundamentally, these are designed just to operate as a light curtain. So if a person is detected either between the door or approaching the door will reverse and reopen again. But of course, it's quite intuitively clear that if there is a camera, you can do much more than that. So if you've got a 3D ToF sensor, then when a person passes through that area of concern, in this case, an intensity image is captured. And here you see in step 1, 2, and 3, first of all, the door empty, then the person entering into the lift, eventually selecting a floor where to go, and then arriving, landing on another floor, and getting out. With some image processing power and some artificial intelligence, it's quite simple to extract and implement people counting functionality out of it. And this would be the example number 1. A second example is that actually to comply to these new standards for North America, there is also the possibility to implement it fully just with a 3D ToF sensor, which requires higher quality in capturing the image. And in that case, no light curtain is required anymore, as you can see here in the picture. And here in the picture, number 1 and number 2, you see an example of 2 persons in this case, but the image has a much higher quality, entering, traveling with the lift, and then leaving the lift. And here also, I would say, quite simple with image processing to extract and being able to count the people entering and leaving the car of the elevator, so also knowing how many people are inside the car right now. And these are quite, I would say, trivial example, because there is a camera behind that. But what's more surprising is actually also with just a simple light curtain, you can do that. A light curtain is actually a camera. Maybe few people think about it, but when a person passes through the beams of the light curtain, an image is captured. We call it a line image. And this is exactly what I'm showing here. So again, so these are now an example of a light curtain. We call them smart light curtain that can capture an image. So on the bottom side here, in addition to the image from the light curtain here, there is actually a real camera in the car just to make sure that the data were collected were always consistent. And on the right side, above, you see a regular trip where this person, this woman, gets into the car at 10:29 actually, and 30 seconds after leaves the car. In the zoom of this line image captured by the light curtain, you see the woman entering, which is exactly the same as happening here. Of course, that's another device, and the same person leaving the car. So again here, with image processing and some artificial intelligence, it's quite relatively simple to capture that this is a person and start counting a person based on it. And this just with a light curtain. There is though a challenge in that. And the challenge is that the scan image doesn't provide the direction. Why? Because the image you see in the X horizontal axis, it's actually timed. So whether a person enters or leaves the car, the image we get, it's always the same. So we need additional data points in order to do a sensor fusion and understand, find out, yes, if the person enters or leaves the car. By aggregating data from the light curtain image and an accelerometer that detects the movement on the car, we can quite precisely detect whether a person it's entering or leaving the car. Also in that case, with a simple light curtain, we can implement people counting functionality. Here, a second example, a bit more complex example, just the same technology, the same setup, the same car, but with two persons entering and leaving the car. Again, the same, I would say, extraordinary result. We could really catch exactly what's going on with the car. Maybe just if you notice, when the first person is leaving, you can see this straight line, and actually this corresponds exactly to this woman having her arm like that. Of course, the resolution of the image is much lower, but that's more than sufficient to capture the number of people entering and leaving a Lyft car. Now, I leave a bit the topic of technology. This was a bit of an introduction, what kind of technology can enable that. And now I switch a bit to the kind of value you can do with this data, because again, digital transformation is about exploiting the data and giving a business value to it. So, and fundamentally there are two business spaces, two areas where this can be applied. One space is the Lyft business itself, so the Lyft companies. And the second part we'll see later on are the building owners. So that's why I'm talking about smart buildings, right? And here I just provided some examples, but there are for sure more that you can think about and elaborate about. So a first area for really inside the Lyft business, it's about increasing passenger safety. By having the knowledge on how many people are entering and leaving a car, you can actually increase the passenger safety. So because you know that there is someone in the car, the elevator, let's take the scenario of a passenger trapped inside a blocked elevator. I don't need to wait that the poor guy in the lift presses the alarm button. I already know that. I can generate an alarm. So this can have a tremendous impact in saving life in certain conditions. Another scenario, still in the area of passenger safety, it's a scenario where the number of people present in the car has to be limited. So let's go back to standard Lyft functionality, like overload, full load. Of course, this can be an additional and complementary, I'm not saying exclusive, maybe not, but an additional data point to ensure that your cabin is full or not, or eventually overloaded or not. So you have additional information in order to detect that. Other scenario that we learned during the COVID-19 pandemic is the fact that due to social distancing rule, you can also control and ensure that no more than a certain amount of people are in the car, depending on the car size. So for instance, it's in a small car, only one people at a time can travel. Thanks to this kind of data and information, you can ensure that this is happening. Another in general, area, still located in the lift business area. It's about lift design in general, and fundamentally the topic of optimizing the traffic management in an elevator. Thanks to this information, you can really make informed decision in the scope of the modernization, having those information. So you know right now, or let's say this year, this month, how this elevator is used. You cannot just decide based on historical assumption how you want to modernize your elevator. Thanks to real data, you can really make your elevator fulfilling the experience of every passenger, so that it can avoid waiting at rush hour at peak time. But of course, as I mentioned before, the potential of traffic data collected goes beyond the lift business itself, goes into the business owner, the building owner. So I talk here in general about smart buildings, and the two topics that comes up naturally is the topic people flow in the entire building, where the elevator is part of it. Again, the elevator, it's a transportation mean, but at the same time, it becomes also a sensor, a guy providing data about what's going on in my building, and also for energy management. Here, in this slide, I just wanted to provide you two visualizations, two out of many, about this kind of data we collect, just to make, because data becomes abstract and dry without visualizing it. We human beings, we understand data once we see data, right? And just to show you, based on this very simple sensor, what kind of data you can extract. On the left side, here you see the representation of a 20 stories, a 20-floor elevator, and the heat map utilization usage here on the horizontal axis. So where every line, it's 1 hour. And here, it already visually, you can, at a glance, understand how this elevator is used, thanks to this data collected. But even more, since we count and we know how many people are entering, where these people are living, we can even visualize the distribution of a passenger over the same, in the same building over 24 hours, over 1 day. So here you see that primarily people are entering at floor 1, then there is a second amount of percentage at floor 12, yes, and so on. And then you see the distribution of the people in the building over time, thanks to this collected data. And there are many more examples. So this is just, yes. Understanding building usage trend is also crucial for optimization, right? Building manager needs to ensure optimal use of resources, such as energy and space. And thanks to this data-driven approach, building manager can base their decision on near real-time people flow data, rather than, as I mentioned already before, relying on past assumptions. Reducing energy consumption while maintaining comfort level remains a major challenge in smart building, and for that you need real-time data. Yes. So, and especially for building-wide processes, you can automatize the efficiency through occupancy-based control. So depending on the number of occupants in the building, the heating system, the ventilation, the air conditioning, the light system can be regulated and so on. And of course, again, thanks to all this data collected. On top of that, there is also, again, applied, in this case, not to the elevator business, but to the entire building, the topic safety. Because if you know how many people are in the building, where they are, and so on, you can also increase the safety in the building, because there are circumstances where there is a maximum occupancy limited in the building. For instance, under a fire, safety regulation, or again, what we learned during COVID time, due to social distancing rule. Yes, optimization of the people flow is also extremely important in large event facility, during concert, sporting event, etc. Last but not least, people flow can also be very useful to prove the commercial value of a real estate, justifying the rent or the sales price of a particular property, right? Another good example is a convention center, right, where organizer can share traffic data with exhibitors for them to calculate the return of investment of a specific show booth. And I come to the conclusion, I don't know if I'm in time or not, then I accelerate. So I started saying that digital transformation is the driving force behind the development of smart building. And I repeat that. Data, it's at the heart of any digital transformation. It's all about collecting data and capturing data, and as far as possible, avoiding adding sensor for that, because usually a lot of data are already there. It's just about unlocking the data that are already present in the system. And the more data sources on people flow become available, the more application for sustainable, safe, and life-enhancing building in cities can be discovered in the future. Yes, and I just finished by saying that Lift become counting sensor for smart building, even with very simple and conventional devices. And with that, I'm done.
Excellent. Thank you very much.
You're welcome.